Now, suppose we have two constraints instead of having just one constraint. Suppose we end up having two constraints. Let's see what do we have here. I'm going to go over one example so you see when to work with two constraints using Lagrange multipliers, what to do. Find the maximum value of the function f of x, y, and z, which is defined as x plus 2y plus 3z on the curve of intersection of the plane and the cylinder. So the equation of the plane is x minus y plus z equals to 1, and the cylinder x squared plus y squared equals to 1. So as you can see, here you have two constraints. What are we trying to do? We're trying to maximize the value of this function. So in general, when you have two constraints, you're going to find the gradient of your function f and set it equals to the linear combination of the gradient of the constraints given to you. So you're going to have lambda times the gradient of the first constraint. For example, this is your g, the gradient of g plus, well, let us, for example, call it mu times the gradient of the second constraint. Let's call it h. Okay. Do the calculus, then move on to the algebra to solve for lambda and your mu. Okay. Step by step, one by one. The gradient of f1, comma 2, comma 3 equals to lambda, the gradient of g1, negative 1 and 1, plus mu times the gradient of h, which is 2x, 2y, and of course, 0. There you go. So what do we have here? 1, don't forget to distribute lambda and mu into parentheses. 1 is equal to lambda plus 2 mu x. 2 is equal to negative lambda plus 2y mu or 2 mu y. And 3 is equal to lambda. Very good. Plus 0. So 0 doesn't count. We found lambda to be 3. Okay. When lambda is equal to 3, and well, if I plug in lambda into the first equation or into the second equation, I'm going to see I have the following relation. Plug in lambda 3 here. 1 is 3 plus 2 mu x. So 2 mu x is negative 2, or mu x is equal to negative 1. My x can be written as negative 1 divided by mu. Keep this. If you plug in lambda here into the second equation, you get 2 equals to negative 3 plus 2y mu. So 2y mu is just 5. So y is equal to 5 divided by 2 mu. We found relation between x and mu, y and mu. Very good. Use your h. H says x squared plus y squared is equal to 1. My x is negative 1 over mu to the second plus 5 over 2 mu to the second equals to 1. It helps us to find the value for the mu. Very well. So we have 1 over mu squared plus 25 over 4 mu squared equals to 1. So my mu squared is equal to, let's see, I have 29 over 4. Mu is plus minus square root of 29 over 2. I found my mu, so now I can find my x and y. Mu is equal to square root of 29 over 2, and x is negative 1 over mu, y is 5 over 2 mu. So my x becomes so here we have, if I plug in positive, I get negative 2 over square root of 29, and my y becomes 5 times the square root of 29. Okay, so here I have 5 over 2, and here I have square root of 29, and 2 and 2, they get canceled out over square root of 29. But if my mu is negative square root of 29 divided by 2, my x, which is negative 1 over mu, my x becomes 2 over square root of 29, and my y, which is 5 over 2 mu, my y becomes, well, here I have negative 5 over square root of 29. This is the way that we find x and y. Now, to find the value for our f, we need to plug those x and y and z into this function and find the values. To find z, you can use g. I have my x and y, and I can use g to find z. G to find z. And eventually, again, to find the f value, you're going to plug in x, y, and z into the f to find the output values. Since I need a little bit of more space, I'm going to erase this part. So z is equal to 1 minus x plus y. So z is equal to 1 plus 2 over square root of 29 and plus 5 over square root of 29, which is square root of 29 plus 7 divided by square root of 29. Or z becomes 1 plus 7. Just write it this way. Too many radicals, 7 over square root of 29, and z in this case, 1 minus x plus y. My z becomes 1 minus 2 over square root of 29 minus 5 over square root of 29, which is 1 minus 7 over square root of 29. So this is my z. And then using x, y, and z for the function itself. F is x, which is negative 2 over square root of 29 plus 10 over square root of 29 and plus 3 plus 21 over square root of 29. okay, which gives me 3, and here you have 29 over square root of 29. You can just rationalize this, you get 3 plus square root of 29. And finally, if I plug in x and y and z into function f, my function f becomes, my x is 2 over square root of 29 plus 2y, so we get negative 10 divided by square root of 29 plus 3z, which is plus 3, minus 21 over square root of 29, which becomes, let's see, I have a 3, and here I have negative 8, negative 29 over square root of 29, or just minus square root of 29. So obviously, this value is the maximum value. It's larger than this output. So this is my maximum. The maximum value of the function is at x equals to negative 2 over square root of 29, 5 over square root of 29, and z equals to 1 plus 7 over square root of 29. That's how we handle two constraints.